Hello viewers, in the previous video we saw what are the various drawbacks of data encryption standards, and in this video we are going to continue that further and discuss what led to the advancement of double encryption standards, that is 2DES, and triple encryption standard, that is 3DES. Okay. So we will first understand what exactly is double DES. As we all know, the original data encryption standard makes use of 56 bits key. If I draw it like this, key, and this is your plain text. This is of size 56 bits. This is 64 bits, right? And the output which comes out of it is again 64 bits. Now what if I apply DES one more time? What if I apply DES again? So over here what will happen is I will make use of another key, right? I will call it as key number 2 and the previous key as key number 1. It will be again of the same size, that is 56 bits. We'll apply DES again, but this time we'll apply it on the output of the first DES block. And whatever output we get, that is my ciphertext. So this is how double encryption standard looks like. It is a very simple architecture. What it does is it actually applies DES twice. So I can write over here, it is basically applied twice or applied 2 times. It's that simple. So that is what is double DES. इसमें कोई changes नहीं है. Only thing is we are going to make use of one key, that is the first key for the first DES block and second key for the second DES block. Now assume that you are sending this message which is of size 64 bits to one of your friends. That friend also needs to apply DES in the same reverse order. That is, the ciphertext will be considered now as the plain text. And उसके ऊपर सबसे पहले key apply होगा key 2, that is in the reverse order, and then the output, whatever output you get, that will be going through another DES block with the key K1 this time, and at the end you will get the same plain text PT1. So this was a very simple implementation of double DES, but why this was done? This was actually done to increase the size of the key. As we saw in the previous video that 2 raised to 56 is not that difficult to crack. It can be cracked very easily. So the researchers tried to increase the security of DES and they actually added 56 bits more to it to make it 2 raised to 112 bits. So now double DES on paper looks very secured because 2 raised to 112 will take exponentially larger time as compared to 2 raised to 56. This was considered at that time. But is it actually going to be secure? No. We'll actually see why this was not that secure as considered to be on paper, right? So what exactly is the weakness we are talking from a long time? Let's understand that with the help of an attack. So the attack which I'm going to discuss over here is called as meet in the middle attack. Meet in the middle attack. This is not to be confused with man in the middle attack. They are almost quite similar. Man in the middle attack is where an attacker comes in between the communication that is happening between the sender and the receiver, or the client and the server. Whereas meet in the middle attack is basically encrypting and decrypting from either ends and coming to a point in the middle so that the attacker is in a position to guess the keys correctly, right? So I will explain this entire scenario, don't be confused, with the help of a proper example. I hope you are able to see this on your screens. Now what exactly happens is, I am going to explain this one by one in detail. Over here, the plain text goes inside that DES block. We are making use of a key K1 and we are getting a ciphertext. Now this ciphertext is a temporary ciphertext. Why? Because we are applying double DES. So this ciphertext will again be encrypted with one more key called K2 and we will get the final ciphertext. Right? So to illustrate this, just have a look at this. The final ciphertext can be expressed using this mathematical expression. It is basically ciphertext is nothing but, let's read it from this side. The plain text is encrypted once with the help of a key K1. Whatever is the output, that is nothing but your temporary ciphertext. This temporary ciphertext is again encrypted with a key K2, and then only we get the final ciphertext. I hope this is making the things clear. Now, in reality, this meet in the middle attack actually makes use of 2 raised to 112 possible combinations, because there are two keys, each of 56 bits. So at the end, 2 raised to 112 possible combinations are required to break into the double DS encryption. But to keep things simple, I am making use of a 2-bit encryption model just to illustrate the process. So what exactly happens in this attack is, the attacker will have access to the final ciphertext. Obviously, because the attacker cannot see what the plain text is, the attacker only has access to the final ciphertext. Now what else does the attacker know? Apart from these, the attacker has also got access to one more thing, that is the plain text. Now what exactly is this? There is one attack called as a known plain text attack. So over here what is happening is, the attacker is not interested in finding the plain text only once and that's it. The attacker wants to know what are the keys, because if the attacker has access to the keys, the entire encryption model collapses, right? So that is why we are assuming that the attacker has also got access to the plain text. So in short, we are having three things known to the attacker: the ciphertext, which is public, it's a 2-bit encryption. Obviously the attacker will try to guess this. We are assuming that the attacker has crossed that stage and he or she knows that it's a 2-bit encryption model. Fine. So these two things are already known by the attacker. Third thing is nothing but, we are assuming that the attacker has access to the plain text as well. That is what we call as a known plain text attack, right? Fine. So these three things are known by the attacker. Now let's go back and see this diagram. So what the attacker will do is, the attacker will apply the known plain text over here. Obviously, if the attacker knows that the key size is 2 bits, the plain texts are nothing but 00, 01, 10 and 11. That is what is known plain text attack, right? So the attacker will make a table, or the attacker will manage a table or maintain a table at both the sender's end and the receiver's end. So what he will do is, he or she will do is, he will maintain a table, he or she will maintain a table with 2 columns, key and ciphertext. So the attacker will do two things simultaneously. The attacker will encrypt from the left hand side and decrypt from the right hand side. So now what is happening? The attacker will encrypt these known plain text values with the keys. Okay, so I'm assuming that the attacker is taking one value 10. So let's assume the plain text is 10. Fine. So what will happen? This plain text 10 will be applied with 4 different combinations of keys, that is K1. So this 10 along with the key 00, 01, 10 and 11 will give 4 different outputs. So the attacker maintains and records them in a table, that is A, X, C and B, just for example. So these are the 4 values which the attacker got after applying the key K1, that is 00, 01, 10 and 11 on the plaintext 10. Clear? The same thing in the reverse order will be done from the receiver's end. So the attacker will decrypt this final ciphertext which he or she has access to along with the key K2. This time again the key will remain of the same order 00, 01, 10, 11, and the attacker will simultaneously maintain the plain text values as well. What is plain text now? Because we are decrypting, so we are considering this as the plain text, right? So if you notice over here, there will be one value which is common in both the tables. For example, over here for the key 01 we are getting an answer as X, that is if we are encrypting from the left hand side we are getting an answer as X. Similarly, while decrypting from the right hand side for the key 10 we are again getting the answer as X. So if we are decrypting from the right hand side we are getting X, if we are encrypting from the left hand side we are getting X. But what are those keys? The keys are nothing but 01 and K2 is nothing but 10. So this is how the attacker will get access to the keys which are used for encryption. I hope you got the understanding. I hope you got the concept. It is basically very simple. There will be a matching entry in both the tables. Okay, we have to simply refer the keys using which the message was encrypted from the left hand side and decrypted from the right hand side respectively. So this was just a small implementation to show you how the meet in the middle attack works. This actually will not hold good in the real life. In real life scenarios, there will be 2 raised to 112 possible values. So basically that table will not hold only 1 or 2 values or 4 values. It will have 2 raised to 112 possible combination of values, and there will be an algorithm running in the background which will keep on checking where the key matches, where the values matches, and the corresponding keys are fetched. This looks very difficult, but nowadays with the use of the modern day computers, this process is really very simple. It's basically a table lookup and you will get the answer, right? So this was the inherent drawback present in double DES. So with this we come to the end of the weaknesses present in double DES. In the next video we are going to learn about what exactly is triple DES and how it has enhanced the security of DES 3 times. So stay tuned, take care, God bless you all.